I'm finally ready. So as Jan already introduced, I'll talk about matrix RTC and element call, but it turned out it will be mostly matrix RTC. Oh, like this? Is that better? Thanks. It will be mostly matrix RTC and just a tiny little bit of element call. And I put it the subtitle, The Journey to a Stable, Scalable, Flexible, Real-Time Communication Platform on Matrix. So even though we are basically mainly working on building element call, we're also trying to make it a very stable foundation for any kind of real-time application you want to build on top of Matrix. And before we go into too much technical things, I want to talk about something a couple of years back, and that is how the Greek gods communicated. At least how they communicated when their usual system of delivery was out of order. So what they did is they had a chalkboard on the Olymp, and then whenever there was an occasion where they wanted to communicate something, they just choose a random human being and force that human being to run to the Olymp and write a message on the chalkboard. And that sounds like a pretty feasible idea, but what they ended up with were a lot of problems. So one was if two people kind of simultaneously wanted to, for instance, schedule a meeting and with each other, and then they both sent humans. One took longer, one a little shorter. And even though they checked what the board said before, they ended up overriding their own messages. And then, yeah, that was super annoying. And another problem sometimes occurred that they wanted to do a meeting for the whole fellowship. And then one person came up with the idea and another one, for example, Zeus and Hera. And they announced a meeting, one outside, the other one inside, and then the first messenger arrived, wrote inside, a couple of people checked, went inside for the meeting, and then the other messenger arrived, updated it because of the latency, and then the last people who were joining a little later went outside because that's what the board now said. So even though that sounded good, it caused a lot of issues. And now we look at the almighty Goddish chalkboard and see what is up for today's agenda. So basically, I'm stopping with the whole Greek thing for now, and this was just for the beginning in case you're worrying. So we'll first talk about the original group calling, which is what Matthew also had in his talk, the MSC2023, and why we made changes to it. So basically, there are a couple of implementations on it, and even element call was implemented on it. And I'll just talk you through so we're all on the same page, and then see what changes we wanted to do. And then basically, most of the changes are LiveKit, and I'll just talk you through what that exactly means and how that is entangled with the rest of the calling architecture. And then the third part will be about our new architecture or the new structure. And we call this matrix RTC because it's somewhat detached from specific calling. That was the case from the beginning, but it's now even more. And we just show how we implement the findings and changes. And then kind of the elephant in the room with the whole, we switched to LiveKit. Is this now like a full marriage, Matrix and LiveKit, which would be amazing because they're a very similar project. They are all open protocols which everybody can use and everybody can empower things with. But it might also raise concerns because that would imply we always have single forwarding units and you have to host a server. So basically, can we get full mesh back again, which was the initial idea of the whole thing. And then at the end, I'll do one slide about element call just to see where we're at with element call. So full mesh calls. So basically, I did a little diagram. Just a little overview. So basically in the bottom, we have everything client-side related. At the top, we have the server components. And on the server, we have the very prominent call event. So whenever you want to create a real-time communication session, you create a call event, which is just a state event containing all the information like title and other related things. And then we have the membership events, which are one event per participant where all the call member-specific information is stored. So everybody has an overview. And then, at the bottom, we have those green bars as communication channels over matrix, core matrix communication things. So those are two device messages, and those are just CS API calls. And we have the web RTC connection. So I now want to just walk you through how a call setup or a call lifecycle would look like. In the first step, one of the users who's interested in having a call is just posting a call event. So the big event at the top is created, and the call is open. And then people start to see, oh, there's a call event, I want to participate, and they send their member events. And with the help of those member events, people can figure out whom they want to connect to. And the actual connection between the clients, because we are in a full mesh world, is then done over a WebRTC channel, but therefore we have to negotiate candidates. That's just a thing. Like if you want to do the WebRTC channel, you just have to do some negotiation to figure out how exactly that WebRTC connection should look like. And that is done over 2 device messages. So basically we go through this process. There's more details, but don't want to go into too much detail there today. And then at some point in time, they decide one person is pushing a matrix, a WebRTC connection to the other client, and then there is an established connection, and yeah, we have a option to exchange real-time media data. And then as soon as, whoa, I guess you saw the diagram long enough so I can just continue talking. So as soon as the one of the participants decides that this call is over now, they just update the call event at the top and put it, should I try to reconnect? Could that be of help? We'll just wait. So they update the call event, put it into a terminate state, and oh, this was literally just my computer dying. Oh, thanks. Yeah, that wouldn't have recovered. So they set the call event to terminated, and everybody disconnects. So this was basically the theory, and then after implementing it and playing around with it, we ran in a couple of issues. So the first one is we have a single WebRTC connection, and we don't really have ownership of this WebRTC connection, and that's kind of why I did the whole Greek gods beginning example. That's very similar to our chalkboard. If we don't have ownership of the chalkboard, if all gods use the same thing, they can override their own claims or each other claims. And in the WebRTC situation, this looks like that we have so-called SDP candidates. So the signaling description protocol, I think it's what it's called. I noted it down, might be wrong. So basically, if 2 people want to change how the signaling looks like, or how the connection looks like, for example, both people want to start a screen sharing, then they both update the SDP, but one will be the quicker one, and then they override each other. So basically, you can end up in a situation where we both want to screen share, but one of us just cannot because we get overwritten. So what the solution for this is that you have 2 connections, one where person A is sending to person B, and the other one where person B is sending to person A. But that would incline a pretty big refactor. At the same time, we also had lots of unable to decrypts. Like that was a time in Matrix where the unable to decrypt state was not too stable before the Rust SDKs, and that also made it super tough because then this process was very, very unstable. So we also sometimes didn't end up with an RTC connection in the first place. And we also didn't really have a recovery system because the way those candidates work is that you first go back and forth, and then you push your stream to the other side, and then you have an established connection. But there's not really a way to say, oh, I think I'm missing a stream from this member event, so let's just pull those streams from the other participant. And that basically all ended up in a what we call split brain situation. So different people were seeing different versions of the call, and nobody was really happy. So same as the gods, we also had like a non too pleasant experience. And on top of all this, our actual goal wasn't to like debug the whole MSC341 situation, but we wanted to do is getting larger conferences. That was our main goal. So that all kind of was a little bit annoying. And then the more we researched, we saw we are actually also not really solving new problems. Like the more we investigated, the more it looked like we would rebuild something very similar to LiveKit. And just to see how similar our plans were with LiveKit, what LiveKit already delivers, I prepared this slide. So on the left-hand side, it's the exact same list from before. And on the right-hand side, we see what LiveKit is doing. So LiveKit, just as a quick summary, is just a wrapper around WebRTC with an SFU. So they kind of put abstractions on top of the core communication things, and basically those abstractions are very clean and they remove all the pitfalls you could run into when doing it yourself. And that's also the goal with Matrix RTC, that we kind of want to have a system where all the pitfalls are taken care of and you can just have something that works. So our single WebRTC connection and the ownership problem, LiveKit uses 2 WebRTC connections between the SFU and you from in their design. Then the 2 devices unable to decrypt situation also is kind of solved, because LiveKit uses a WebSocket connection to connect between you and the SFU. And then no recovery system, and the pulling streams also wasn't available. They have a very proven protocol which is taking care of almost all the edge cases one could think of. I mean, I don't know, but I see that it's very stable, and that makes me expect that they take care of most of the edge cases. Probably there are some edge cases which are so specific that even they didn't take care of yet. And then our goal is to work on larger conferences, is that LiveKit also ships a fully built open source SFU. So that was a very great fit. The only thing which kind of was concerning is that our signaling, which went over 2 devices before and they are encrypted, now uses something entirely unrelated to Matrix, the WebSockets connection. But if you think about it, as soon as you have an SFU in place, and that SFU is responsible for negotiating the WebRTC streams, then you basically, by design, need the SFU to, we'll recover quickly, need to know about what kind of signaling messages you're sending to the SFU. There's no way around it, because if they are encrypted on the SFU, then the SFU can't really do anything with it. So basically, this metadata leak will always be the case if you use an SFU. And therefore, it also doesn't really matter if it's Matrix-specific communication protocol or WebSockets. So it doesn't look pretty on first sight, but it's basically a given that we have to do it like this. So then we kind of had this whole LiveKit vision, and now the question was, how do we implement LiveKit in our current infrastructure? How can we make as little changes as possible and still ship LiveKit fairly quickly? And our solution was to just put the LiveKit URL into the call event. Because our call event, if you remember, that's the one thing you create for having one central information point about the call. And in there, we put the LiveKit URL, so everybody knows, and the alias, so basically the URL and the alias, it's the whole LiveKit information blob. So we know the memberships, then we can just check out this URL, know where to connect to, know the alias of the room, and then we'll have this separate network, basically, with the LiveKit SFU where all the clients connect to. And they'll all end up in the same room, because the LiveKit URL contains this information, and that's part of the room state, and all members are hopefully part of the room state. And there's another cool thing which we could leverage from Matrix, and that is this LiveKit SFU, so it can't be abused by other projects just using your resources, has an authentication system over OpenID tokens. And those are not the OIDC thing Matthew presented this morning. Those are a pretty old system, which we also used for Jitsi, where you can just ask the home server to give you a token so you can prove that you're from this home server. And we could directly reuse the setup, which is really old, and in the CS API to basically authenticate with the LiveKit SFU. So that was a very quick implementation, and it worked fairly decent until it started to also cause some issues. And this is basically the same figure of the one I showed before. But here I'm presenting one specific failure mode. So basically, if we are listening to changes on the LiveKit SFU, and this doesn't sound necessary on first sight, but if you have a call event and then something changes, basically your host of the LiveKit SFU changes their domain for whatever reason, or they have to do a redeployment and change something in the LiveKit URL, then you, of course, have to kind of also update the calls to now use this new LiveKit instance. So we kind of build in a system so the clients can bring their LiveKit URL, and if there's a new version of element call, they could bring a new version and then update the call event. But this kind of allowed for attack surface, or also failure mode, whatever you want to look at it, that if we have one confused client or evil client or non-updated client, and the call was working with the two clients on the left-hand side, and then this client was joining, updating the LiveKit URL with something broken because old configuration or just being evil, then you basically ruin the experience for everyone. Because then people listen to the update, they try to connect to the new LiveKit URL, and nothing works anymore. And to sum up, one can say one broken or malicious client can break it for everyone. And that's something which we figured out we always have to keep in mind. That's like very, very bad, especially in a distributed system. Like if one person can mess it up for everyone, that's a really bad design for a distributed system. And there's another failure mode. Basically, if you don't listen to the changes and you just say, well, we just take whatever is in the call event on connection, and then we just keep this because then we cannot run into connecting to something broken, then you still can have the a split brain-like experience where the first client is connecting with the right LiveKit URL, then the second client, the confused client, like those indices right here, they are basically the order of connection, is connecting, updating the LiveKit URL to something broken, and then the third client who's not broken, but just something different. And then the third client is connecting, and we end up in 2 LiveKit instances. And that's also a failure mode. So what did we do? We basically noticed that we don't need the call event. Like, it's enough if we just have the call member events. And then we kind of mitigate this Greek god situation where they have one chalkboard and they kind of all have ownership over this chalkboard and everything gets messy. Instead, they all have basically their individual chalkboards, which are the call member events now. And we compute the actual call event. So here we have the new structure. Now the server just has call member events, no call event itself anymore. And on the client side, we have a computation function which takes all the member events, the array of members, and then computes a call event, kind of. And that is really good because we now don't have an ownership, or we have a proper, clear ownership model where one client has one call member event which can only be changed by this one client and nobody else. And this computed event also gives us some good features because for once, the call event is not necessary anymore. And for glaring situations where we are not sure what the actual truth is or where people are in like different states and there is a conflict which needs to be figured out, we can make this very transparent in our call event. So for instance, we could either say, so everybody is now containing the LiveKit URL which they are connected to, because the call event isn't there anymore. Basically, all the call event data is now in the call member events. And we could either say we just take the SFU from the first one who joined. And then the first one who joined can be determined by the timestamp of the events. And then this is a glaring algorithm which always converges to the same event. Or another situation could be that we just have one admin in the room and we just say we'll always use whatever the admin is having. Or we can somewhat implement a democratic approach, which could be a little bit more messy, where we say if there's like a significant mass using solution A, then we all go to solution A if we join to this whole thing. So basically, we can application dependent, we can basically choose whatever is the best for our use case. And just to walk through a failure mode now, so if we have a confused client again, this client messes up his or her call event and is connected to the wrong FOKI or the wrong LiveKit single forwarding unit. But it doesn't break the experience for everyone. It's just this one specific member who is then having issues. And that's a much more stable and sophisticated situation we are in, where it's much easier to move forward. So basically, this moves the whole matrix situation from what we had before on the left-hand side, one call event, members attached, to a new world where it's just a room is basically always in the state where it could be a RTC session. In a room, people just go ahead, put their member events in there, and then that's an RTC session. And there can, of course, still be multiple sub-rooms or multiple meshes by just claiming, I'm a call member, but I want to do this kind of thing. I want to do a computer game, a real-time computer game, and the other one is saying, I want to do a video chat, and it all works, even though there's no call event they attach to. And the next step I want to do in this presentation is to have a closer look at what this call member event looks like. So on the right-hand side, this is our new solution, just a very flat structure, call member events, and that's it. And this is how they are structured. So we have a content event, like every state event, and in there we have an array of memberships. Because of course it can also be possible that one user is connected to multiple sessions in one room. In this case, there's only one membership. And at the top, we have everything that is actually Matrix RTC specific. And those are the things which are really needed to connect to each other. So we have a device ID, an expires time, which is we can talk about this later if you're interested, but not too important for now. And then we have the Foki active part. That is very important because that contains all the information which is required to connect to this specific member. And then at the end, we have the application key. And this makes it possible that we can have multiple applications for different membership events. And at the bottom, there's application-specific data. So this is also kind of new, that basically with the value of application, you define whatever values there are in this member event. And that also makes it super flexible, because now the application itself is empowered to maybe add additional informations. So for calling, we figured that it's very important to maybe also have a call ID. So we can have 2 calls in one room, and each call would have a different call ID. Then we figured out a concept for scopes, which is also interesting, but won't be covered in detail in this talk. So that's just configuration for this one specific application. And those are grayed out because they're currently not in use, but discussions about it happened. And I think even Matthew hinted it in his talk this morning, that we might use room events for the whole ringing for the whole ringing infrastructure. And that could also be thought of. So basically, one person is sending a room event, and then a membership event linked to this one room event, and then people receiving this room event, the client can react by ringing, and then also create a member event to this linked event. So they all know they are in the same call. And we can even think about, that's not call specific, that's just some random shared or individual data. And with the glaring algorithm, we can then decide what I want to have as my shared or individual data. And that's all application specific. And here, I just made a very broad example. So we're going now really far away from calling. So if we imagine something like third room, we could even do a first step optimization where we just have in the shared data field, we have somewhat the chunk ID, for example, or the space ID of a specific user in one huge room. And then you can filter, before even doing any WebRTC connections, filter out a bunch of users which are not interesting for you because they are so far away or in different rooms. And you only connect on a huge world with the ones which are in a similar chunk than you. So there are like lots of things you can do with this, but all application specific. So now to the big topic, the revival of full mesh. So basically, if we just go back like this, active Foki, in this slide, I just said this is how you connect to the user. This can actually be something, so this has a type and can be something which just makes sense. So basically, what we want to do is that this Foki, or like LiveKit at the moment, is interchangeable. So it's not part of the Matrix RTC spec per se. That's also all up for discussion, of course, but our current plan is that this is not part of Matrix RTC period, but it's something that is another component which is also interchangeable. And basically, you can think of this active Foki as the route or method to connect to a specific member, and there can be different infrastructures for this. And of course, LiveKit is our basically prime example at the moment, but full mesh could be revived as another infrastructure for Matrix RTC. And here I have a list of the requirements a infrastructure has to provide, and that's just a procedure to request a stream from any of the members with the information in this field. Then it has to be possible to send a stream, push a stream with the information of the active Foki to a specific member. And then basically the counterparts, like reacting to those requests and pull and push requests. So if somebody's pulling from me, I need to have a procedure how to react to this and provide the stream. And if somebody is pushing a stream onto me, I have to have a procedure how to accept the stream. And that is basically what the infrastructure component needs to provide. And LiveKit provides this with the WebSocket API. And we could and would like to, and let's see what the next steps are, could also imagine that this is totally feasible to basically do with full mesh as well. So we would do some changes because we think the two-stream solution is very, very good for not having ownership of, like, not have shared ownership of this one connection. And we really would like to have the requesting stream and providing stream implementation, so we can also recover and pull streams if we somehow messed up the situation. But then there's no real reason why full mesh shouldn't be also a possible infrastructure. So basically, to now give the full picture how this all evolved and what the current plans are, is that we have those three kind of specification layers. So we have matrix RTC, and this is just how the state event looks like. So what we looked in at the beginning, like we don't have the state event for the call event anymore, we just have member events, and the member events have a section for app-specific parts, and they have a section for the matrix RTC-specific parts. And then we have app-specific specifications. So m.call could just be a general call specification, which has all the features a call has. Or we could also do something m.elementCall, which then might have, or io.element.call, which might have element call specific features inside the app specific section. Or if you want to do a race game over matrix RTC or third room, then this would be an app specific specification. So you can also have different clients for a implementation, especially for mcall. It's totally feasible that you want to have not just element call, but different clients. And then the last piece is the infrastructure. And this is what we have at the bottom, which can be either LiveKit or full mesh, or maybe there's something much, much better in the future. So basically, we want to have it kind of similar to what we have in Matrix with encryption, where this is also a replaceable component. So if there's something new, which is just much better than LiveKit, it's not enforced that we have LiveKit. It's just if the people say, connect to me with LiveKit, then you do so. But if they say, connect to me with this new amazing technology, then you do it with the new amazing technology. Or the question we had this morning with what do we do in a peer-to-peer world? Maybe there's an amazing solution in the peer-to-peer world. Then there could be an infrastructure for peer-to-peer. And yeah, so basically that also makes it possible to have the infrastructure can then also have an entirely independent communication system like we have with WebSocket for LiveKit or two-device messages. And just to bring this again into the connection with the call events, like the call member events, I just put boxes around the different sections. So we just talked about matrix RTC, app-specific specification and the infrastructure. And this is what we can see here on the right-hand side. So the matrix RTC block is basically just those 4 fields. Then the infrastructure is whatever we have in Foki active. And there's no reason why there shouldn't be 2 different infrastructures happening at the same time. Like there can be full mesh and LiveKit at the same time. It just would be 2 fields in this array. That's also why it's an array. And then we have the application-specific things, which is just a basically unlimited size, whatever the application decide is necessary for them to work properly. So that's all about the matrix RTC part. And we'll now just have a quick look at element call. I'm super glad I don't have to do demos anymore because I'm really not used to do demos on stage, and Matthew is, so that's really lucky for me. But I want to talk a little bit about the encryption, because the encryption was kind of a very cool story, how all the stars aligned, where we had Firefox shipping insertable streams and LiveKit adding support for encryption, not only just single shared key encryption, but also per sender encryption, and we reaching the place where we really have resources and all the matrix RTC foundation things are solved, and we had the resource to also look into encryption. And it's also interesting that we have those two different encryption systems. So what Matthew showed this morning, where we have one encryption key for all the members in a room, that is what we use for the single-page application. And there, this also makes a lot of sense, because we don't have a trust or authentication model in the single-page application. You just share a link and then join. And in this case, we are kind of reliant on the key sharing to also happen through a separate network. So you could use Matrix, send the link over Matrix, and then the key sharing also happens over Matrix. But you also could use an encrypted email or a non-encrypted calendar, which kind of would defeat the whole thing with the encryption, but whatever. All this is basically up to the user to make this key sharing secure. And there's nothing we really can do about this. So one key makes a lot of sense for those open rooms where you just join with a link. But if we look at the per device keys, that is really good for embedded mode. So if you have a already existing room, maybe just 2 people or 5 people, and you want to have an encrypted call in this room, then element call actually, or this LiveKit Matrix RTC combination is a very, very good solution, because what we then have is that we have authenticated users, which we know, and we even go and they have a good key sharing system and everybody has a key. And it even goes one step further, that Matrix offers this amazing verification system. So they're not only authenticated, but each device is also verified. So you can be sure that all devices in this room, like only devices which you actually trust, have the keys. And then we can use those keys for per sender encryption. And then we have a very, very, very secure real-time chat system or video conferencing system. I'm not even sure if there's anything else on the market which offers a verification system with emojis or QR codes and then has per device sender keys. The only thing I found is that often they use single sign-on procedures, which is basically the industry standard in secure video conferences. But with the device verification, this is like very, very cool. And what we also achieved is implementing this whole new stack of Matrix RTC and element call. That also just happened with the release on Wednesday. So basically, those are the 2 new news from Wednesday. And yeah, I guess this also sums up my talk. Thanks for listening. And of course, still feel free to play around with call.element.io if you haven't already. And yeah, thanks. Oh, nice. So any questions? Oh, wait, before the questions. So I just had like a little extra note here. So for once, I'm super excited what will be possible to be built on top of Matrix RTC. I mean, we have third room. That's probably the coolest thing you could imagine and is already there. It's sadly still using the older version without the LiveKit SFU and also is kind of on hold. But Nordic also has built something really cool with a RTC solution, also still on the old thing, and I'm like, myself, I'm really interested in their talk and also invite, I mean, I can't really invite you, but I recommend watching the talk, I guess. Okay, then you're open for questions.
Thank you, Timo. Questions, yes.
First of all, thanks. Could you maybe explain very briefly again why the call members event is not affected by malicious manipulation compared to the normal call event?
So basically, you're talking about this slide, right? Where
yes.
Okay, so if we look back to the call event situation, there I kind of try to indicate this with the 2 arrows. So each connection to the call event was a write-read relation. Like every client had a write-read relation with the call event. And that is basically the main thing which made it very vulnerable. So if I'm joining and I decide I want to basically mess around with the current conference, the easiest that I could do is just put this on terminate or do something with this call event. Of course, there could be some permission system that this is not that easy, but it's still an option if not properly set up. And in this new system where you have the call member events, I'm not sure if you are familiar with the concept that if you put the key as your matrix ID, then you basically have ownership of this state event. So nobody else has write access to the state event. And this is what we use for the call member events. So in my call member event, the key of the member, or the state key, I think that's what it's called precisely, will be my matrix ID. And then nobody else can change this member event except me.
Okay, so every participant has its own call member event.
Yes.
Okay, it's not
That
shared.
is-
Okay, got
yeah.
it now.
Oh, thanks. This is really good for me to repeat if I didn't make that clear. So basically, we have 3 clients, then we have also 3 member events. And that's why we have 1 member event per client, and that's where the ownership
All right, thank you.
comes from. Thanks for the question.
How do you deal with the ownership event if one user with one matrix ID uses multiple clients then?
In this case, it would still be the same member event, and just the array of memberships would be much bigger. So basically, of course, that's an issue. So basically, you can mess up your own. So if you have one client and you have another client, then you could basically hack the session of this one client. So maybe this client A is doing third room, client B is doing a video conference. Then the third room client has the potential to mess up with your Foki active of your call. That's a problem, but I guess that's your own fault then. So
At least it's just you who's affected.
yeah. So it's
Thank you.
your.
With the element call slide, you said something with per receiver encryption or per sender individual encryption, something.
Yes.
Which makes it super secure. Sounds great. Doesn't that reintroduce the scalability issues of basically full mesh?
So honestly, I think we didn't really do any like larger experiments with, like in the beginning when we have LiveKit deployed for the first time, we had done some scaling tests, but since the encryption implementation, I'm not sure if we did lots of scaling tests. Yeah.
Of course, you create a full mesh to exchange the individual sender keys, but compared to the media, this is just nothing. So that scales beyond the... So let's say for the full mesh, we would say it scales up to 5 to 8 participants, because then the network bandwidth is just saturated. But if you just need to exchange these individual sender keys, there are significantly less data to exchange. So that works.
Yeah, so basically for the SFU, it doesn't really make that big of a difference, because the SFU doesn't decrypt anyways. So it just gets 10 streams, 10 different encryption systems or encryption patterns, but the SFU doesn't care. It forwards those streams, and then you just have 10 corresponding keys, and you just decrypt all all individually. So it could have a performance hit on the client, however.
It could, yes. But if you, let's say, if you're running into basically the same limitation as you would have with Magome, then we could also rely on a smarter algorithm like MLS for distributing the keys here, and then you would have a log-n effort rather than n-square.
Yeah.
When this starts landing in production, or are there any mock-ups how this will probably be implemented in the Element clients? Like, for example, I don't know. I, for example, think Slack kind of nailed it with the huddles, like in a way how to do calls in like day-to-day stuff like that. Do you know how Element will implement Element call later in the clients?
Yeah, thanks for the question. This is actually also a pretty interesting story. So by design, Element call has 2 different backends. It has like the CS API backend and the widget API backend. And since the actual communication you need between Element call and the server is quite limited, it's basically just the exchange of the state events, and the rest is then happening between the SFU and Element call. It's not that hard to get this done over the widget API as well. So what we're doing is basically take Element call with the widget backend and then just embed it in the clients. So basically then the client is still taking care of the encryption part, which you don't need for state events, but if we have room events involved as well, and the authentication part and the login and everything, while Element call is just building up the WebRTC connections or WebRTC connections to LiveKit. And this is really cool because that also makes it possible to basically embed it into the new X clients fairly quickly. So what we also have been spending lots of time on is basically having the widget API implemented in the REST SDK so that clients using, so that's also something pretty cool, I think, which is still somewhat in the future, but not too far, is that if the REST SDK supports the widget API, then we might see a lot of more clients supporting the full widget API, with also sending room events and receiving room events, and things like Fractal, for example. I could imagine also could implement widgets. And then element call is, since element call is also taking care of the state, so basically you really only have to put an element call into the room, and then you just have to do one check. Is there a membership event of type mcall with application type mcall? Then you just start up the widget and it will do everything. Like it will just see, oh, there's member events. What's the for key it's using? Oh, it's using LiveKit. So I know that I have to connect to LiveKit and it just works. So basically the burden of the client implementing a call, if they are willing to use element call in a web view, is literally just checking if there are call events, call member events. If there are, show the web view, and it will take care of everything. And then, of course, you can go ahead and be like, oh, I also want to count how many member events there is and show in the header the amount of people who are in the call currently, even though the web view isn't started. But that's all sugar on top. If you just check if it's there, you add the iframe, then you basically have a client with working calls. And they even would be encrypted as soon as that's implemented. So it's all pretty cool and pretty low friction to get calls into other clients then.
Okay. In this case, you would be in need to have the permission set similar to send an mcall event as well as to alter the widget?
Yes.
So this would be probably then linked to not fail. So I cannot start a call, but I am not allowed to open a widget, for example, in the client.
I think you have to repeat the question. I'm not entirely sure if I...
Okay, so we have these m.call events,
Yes.
these new ones.
Yes.
And there's also an event type to alter widgets, right?
Okay, yeah. So basically the widget part is just for those kind of static widgets, which are like fully attached to the room. And what we usually do, I mean, that's one option. You could literally just go ahead and do this /add_widget and then pass the element call URL with a couple of additional parameters. But what we do if we do something like a client pretending to have native call support is that we create a so-called virtual widget. So it never reaches the room state. It's just the client, whatever is in the room state, which is just the widget ID. And I think that's the only thing which is really, really important. Oh, and the URL, like the widget ID and the URL for the content of the iframe. We basically just generate those two values. And then we have a virtual widget. We just create the iframe with the URL. And then we pass the widget ID to the REST SDK so it knows which iframe to target. And then you don't have to mess with the room state at all, which is also a little bit cleaner because then otherwise you would have other clients which don't support the full widget API, just parts of it, and they would still list the widget. So yeah, for calling, we now opted, at least for element X and element web, to have it as a virtual widget, and then you don't need permission for this. So you just need to give the permission, to give the widget permission for the state events, the required state events.
One very short last question. Those virtual widgets, are they part of the spec? Or is it something element specific?
I'm pretty sure they are not part of the spec, but nothing widget related is part of the spec. It's all like a couple of parts of widgets are in MSCs, and then the rest is, so basically, but it's still like, it's two big sections. It's how to define a widget in a room and how to communicate with a widget with those actions. And the actions are mostly all in MSCs, and also how to set it into, but that's really old MSCs. Those are, to some extent, MSCs still in Google Docs, who define, or which define how to put a widget state event. But yeah, the virtual thing is just a hack without, I'm not even sure if this has to be specified, because it's basically just an implementation detail on the client, and the widget is still treated as a fully spec'd widget, basically, or MSC spec'd widget.
Got it. Thank you.
Cool.
how does this new state event work with power levels?
Say it again, with?
With power levels?
Oh, so basically, I think every state event type can be associated with a different power level. But for this one, it's not really important because it's always owned by one specific member. So it's actually a really good question, and I just noticed that I think about it properly for the first time. But I'm pretty sure it's also a non-issue because since you have one member event with one state key as the user ID, implies that you are just the only one being able to interact with that state event. And then if you want to have a call where some people are not allowed to participate, then this would need to be a specific kind of call that basically would need to be something like a breakout room. And then what would make sense in those kind of scenarios is just use the application-specific section and maybe also add, so that could be a breakout room, which is created by one specific user, and maybe you only accept breakout rooms from a user with a specific permission hierarchy level, and then this would list the amount, the users which are allowed in this breakout room. Those kind of things could be imagined, but just from a very technical point of view, that's actually also something I wanted to briefly add as a side note anyway. So thanks for bringing me to that subject now. From a very technical point of view, we also need to be somewhat defensive in how much of a security model we present to the user, because in reality, there is no real method. Like if you have one room, you can't really make security subrooms in this room, because the encryption keys are shared anyways. Like everybody has access to the encryption keys. And if you think that the SFU also isn't like a fully secure system, because somebody could be the owner of the SFU. So we should calculate with the option that some users just download everything that is streamed to the SFU. And of course, that's encrypted, so that's not a problem. But if you are part of the room and you can download everything which is shared through the SFU, then you can always decrypt the streams. So basically, if you really want to have a secure subsystem in the calls, then you kind of have to create a new room. There's no way around it. And that's also why this whole system doesn't really involve a permission system on a synapse space, because it would basically communicate a false sense of security, because there's not, like, as soon as you don't have different encryption keys, there's no real separation between the streams. So that's why we opted to kind of don't put too much permission systems in this. The only thing that is really important is that nobody messes with your membership event, but that's handled by Synapse anyways because of the state key being your matrix ID. So hope that.
Yeah, thank you.
Yeah,
okay.
I think basically the idea is here to separate the moderation bits and pieces from the signaling or matrix RTC session bits and pieces. So in the old world, you had the mcall event and the mcall member events, and you could have different power levels attached to those. So maybe only some moderators or whatever could start a call and others could participate. Since we now just have the mcall member event, so everybody who can start a call can also participate and vice versa. And if you really want to have, if you really want to enforce moderation, you need to have a trusted SFU, and then you can, through using the power levels, give a moderator or an administrator an admin connection to the SFU, and then really enforce that streams are just sent to this and the other person. But this needs a trust relation to the SFU.
Yeah. Yeah. But that's still a really cool train of thought, which I think I also would like to add that, for example, if you remember what I talked about with the linked event, like the idea that ringing might work by posting a room event and then linking to this specific call, and not just a general room call, but like attached to this event. Of course, this room event could again be a ringing type or mcall start, or I don't know, creative idea. Any creative idea could fill in this name. You could, of course, set power levels for this start event. So then everybody could just join in this random room call, but nobody could actually place a proper call. And then if you have like a big company and you only want 2 people to be able to call everybody with like ringing, then you could put permission levels on those custom events. And that, of course, then, since it's all implementation detail now, that, of course, allows you to have like lots of good ideas to separate the permission system there for specific features.
What about just in general writing the state events? Like I'm surprised I can write by default a state event in a room. For instance, could I go into Synapse announce and then add state events with my prefix?
I think there's a permission level for writing state events in general, but most people are on that permission level. Or are they? No, not really. I think that's actually something you have to add. And I also know that for the embedded element call specifically, we also have a settings allow element call, like new element calls in this room. And what that does is basically setting the permission levels so that you're allowed to put the state event in there. Yeah, so basically it would be the member event would probably get a really low permission level, so most people can participate in a RTC session. So, yeah. I mean, there are some state events which are very low permission, for example, just like the general membership things and leaving. That's, of course, also in your permission reach, and we would just treat them similar to those kind of events, where it's like possible for everybody to post a leave event or a membership, a call membership. But that's definitely something that has to be like part of Synapse, and I think that already is part of Synapse, or we are hacking around it by putting the permissions level correctly. That's something, yeah, definitely a solution to it. I don't know how it currently looks like.
Thank you.
Any more questions? No, I don't see any fun.
Cool, then that's it. Thank you so much for listening.
Thank you, Timo.